Multiply rational expressions. Because rational expressions are basically just fractions with polynomials, when we multiply rational expressions, we're going to just follow the same rules that we have for multiplying fractions. So, for example, if we were asked to multiply those two fractions, what would we try to do? Well, either we could multiply them straight across and then do some canceling, or what I like to do is find common factors right at the beginning and cancel when we can. So for example, 5 and 10 cancel partially. 5 is divided by 5 to leave with 1. 10 is divided by 5 to leave with 2. Then we can do the same with the 9 and the 6. Each are divisible by 3. So I divide that by 3, leaves me with 2. Divide that by 3, leaves me with 3. And then I go ahead and simplify. What do I have on top? I have 1 times 3 is 3. And on the bottom, I have 2 times 2 is 4. So if, it's been a while since you've had to simplify fractions like that, I would actually take a little time to review it right now, find some resources to help you do that online, because we want that to be a quick skill so that we can really focus on canceling the polynomials. So here we go. We're going to try to multiply these two rational expressions, which means that we just want to know what we can cancel, right? It's that simple, just like the multiplying fractions. So factor what we can. On the numerator of the first fraction, there's nothing to do, but in the denominator of the second, we can factor this to be x minus 4 times x minus 3, and x squared minus 9 is a difference of squares, so that would be x minus 3 times x plus 3. And in the denominator, nothing to factor, so that's 6x squared. So now we're going to see what cancels. What's the same on the top and the bottom? Well, we have an x minus 3 on the top and an x minus 3 on the bottom, so those are going to cancel with each other. 1x from the numerator is going to cancel with one of the x's on the bottom. So x squared divided by x leaves us with just x. And 2 and 6 can be canceled. 2 divided by 2 is 1, 6 divided by 2 is 3. And then I see nothing else that can be simplified. So left in the numerator is just x plus 3. And in the denominator, what are we left with? Well, we're left with 3x times x minus 4 from there. And so there is our simplified rational expression, or I should say our multiplied rational expressions, simplified as simple as possible. Basically, the same rules are going to apply to this problem. We're just going to have more difficult factoring than we had previously. So 3a squared minus 8a minus 3. How do we factor that? Well, there's no common factors. So what I'm going to have to do is go the long way and just go about factoring this like I know how. So negative 9, I need a negative 9 and a plus 1. So this is going to be 3a squared. So you can either do this off to the side. That's maybe the best way to do it. So let me try to model that. So I'm going to do 3a squared minus 9 plus 1a minus 3. And then I factor by grouping. So I get a minus 3 times, oh, whoops, I didn't take away an a there. That's really important. So that leaves me with 3a plus 1. So make sure you're comfortable factoring, right? You can see that there's going to be a lot of it in these skills, and it's just something that if you're not familiar with yet, you really need to take the time to get consistent with it. So that's my numerator in the first one. The other one I need to spend a little time on is this one down here in the denominator of the second fraction. So I need two numbers that multiply to negative 15 and add to negative 14. So that's going to be negative 15 and plus 1, which means 3a squared minus 15a plus 1a minus 5. And then factor by grouping. And I'm left with a minus 5 times 3a plus 1. So now I've factored, so I just like to do that. I like to factor the most difficult ones off to the side. And now I'm ready to go back to my fraction and say, okay, that top fraction simplified, or factored, I should say, to a minus 3 times 3a plus 1. And the bottom fraction is a difference of squares. So this one I didn't have to do off to the side because I'm very comfortable factoring differences of squares. So I'm just going to do that one directly in the problem. Same with the top one on this other side, because there's no a factor here. Well, you know, you have a's as variables, but because there's no coefficient in front of the squared term, I can just go ahead and factor this because I'm comfortable doing this. This is going to be a plus 5 times a plus 5. And in the denominator, I did that one down there in green, a minus 5 times 3a plus 1. Good. So let's see what happens. Let's cancel what we can. So a minus 3, does that cancel with anything? No, but 3a plus 1 does. Those cancel nicely. Then I have a plus 5 on top and bottom, and that's it. Nothing else is canceling. So I have two a minus 5s on the bottom, but no big deal there. They don't cancel, so they'll just stay as they are. And then I write whatever's left multiplied together on the top, and whatever's left multiplied together in the denominator. And if I wanted to, you can recognize that a minus 5 times itself, we could write that if we wanted as a minus 5 squared. That's not essential, but you know, it looks nice, and your math teacher would be pretty happy if you did it. So if you want, you can take that last step, but the previous step would have been correct as well, so that would have been fine. But either way, that is a more complex problem multiplied together and simplified.